Good morning everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at STEM Tirumuran Institute of Technology. Today we have learned about the subject on WE3601 Protection and Switchgear for 2021 regulations. Today we will discuss the topic on static relay in power system techniques. Content overview of static relay. It outlines the main topics covered in the presentation. It includes static relay overview and comparator types. It helps the audience understand the structure of the presentation. It gives a roadmap of what will be discussed. Static relay overview. Static relay uses electronic circuits instead of moving parts. Directs faults by comparing electrical quantities. So slave relay or thyristor is used for tripping action. Static relays are faster and more reliable than electromagnetic relays. And modern static relays typically incorporate a DC polarized relay as a secondary or slave relay. This slave relay acts slowly as an output mechanism. It does not handle measurement or comparison tasks, but simply uses contacts chosen primarily for its cost effectiveness. Using electromagnetic multi-contact tripping setups is generally more straightforward than assembling an equivalent array of thyristor circuits. Comparators. Comparators are used to compare electrical quantities like voltage and current magnitudes as well as changes in the phase angle between them. They direct difference between normal and fault conditions. These electrical parameters during fault conditions differ noticeably from those observed when the system is operating normally. Static relay circuits are engineered to detect these variations, enabling them to differentiate between normal and fault states. The component within the circuit responsible for evaluating and contrasting the two driving quantities, either by their amplitude or phase, is called the comparator. Comparators come in two main varieties: amplitude comparators and phase comparators. Comparator types. There are two types. One is amplitude comparators and phase comparators. Amplitude comparator compares signal magnitudes. Phase comparators compares phase angle difference. Each type is used for specific protective schemes. Amplitude comparator concept. So in amplitude comparators, this device evaluates the size of two input signals without considering the phase difference. It estimates between on operating input and restraining input. The relay activates a trip command and the operating input's amplitude surpasses that of the restraining input. In phase comparator focuses on the phase relationship between two inputs, ignoring the amplitude values. It triggers an operation if the phase difference between the inputs is less than or equal to 90 degrees. Amplitude comparators. So the amplitude comparators compare two input signals. It operates when the operating signal is greater than the restraining signal. So it does not consider phase difference. It is widely used in overcurrent protection. Begin by examining an amplitude comparator that receives two input signals M and N as depicted in the accompanying figure. This comparator activates when magnitude of M exceeds that of N. So now consider altering the inputs to M plus N and M minus N as illustrated in the figure. So, this inequality holds true only if the phase difference between M and N is less than 90 degrees. A relationship clarified by the phasor diagram in figure 2.20. Phase comparators. Phase comparator compares the phase signal between these two signals. It operates when phase difference is less than 90 degrees. It ignores magnitude of signals. It is mainly used in directional and distance protections. Conversion of comparators. So amplitude and phase comparators can be intercommuted. This is done by modifying inputs to m plus n and m minus n. This method allows flexibility in relay design. It shows the relationship between magnitude and phase comparison. So amplitude comparator working, the comparator operates when m greater than n. After modification, it compares m plus n and m minus n. The relay operates if m plus n greater than m minus n. This condition depends on phase angle between the inputs. In phasor diagram explanation, it shows a different phase angles between the signals. When phase angle is less than 90 degree and the relay operates. If angle is equal or greater than 90 degree, it does not operate. This confirms the comparator working principle. Phase comparators working. It shows different phase angles between the signals. When phase angle is less than 90 degree, the relay operates. If angle is equal or greater than 90 degree, it does not operate. This confirms the comparator working principle. Phase comparators checks the phase difference between the two signals. It operates when angle is less than 90 degree. Modified inputs m plus n and m minus n can also be used. It helps in detecting direction of faults. In this phasor diagram, explain operation and under different phase conditions. They showcase when angle is less than 90 degree, equal 90 degree, and greater than 90 degree. Relay operates only when angle is less than 90 degree. This validates the phase comparator concept. Comparator techniques. Direct comparison is difficult to due to varying signals, so rectification or integration methods are used. Signals are processed before comparison. This improves accuracy of relay operation. Types of amplitude comparators. Different types include rectifier bridge, phase splitting, and sampling comparators. These methods help compare signal magnitudes effectively. Each method has its own advantages. They are used in different protection schemes. Types of phase comparators. Phase comparison can be done using vector product or coincidence methods. These techniques determine phase angle differences. They improve accuracy and speed used in advanced protection systems. Phase comparator advantages. It is simple and fast. It is suitable for directional protection. However, it is sensitive to noise and waveform distortion. Accuracy depends on correct phase measurement. Disadvantages. Amplitude comparators is simple and accurate for magnitude comparison. It is suitable for overcurrent protection. So, however, it cannot detect direction of fault. It may be affected by signal variations. Application is direction relays, distance protection, power system protection schemes, and phase comparison carrier protection. Amplitude comparator advantages: simple design, accurate. It is very accuracy, less affected by phase angle errors, and suitable for overcurrent protection. And disadvantages: it cannot detect direction of fault, affected by variation signal amplitude, slower compared to phase comparator. Application is overcurrent relays, differential protection schemes, voltage comparison relays, power measurement circuits. Reference. This slide lists textbooks and sources used. It includes standards authors like C.L. Barba and J.B. Gupta. These references provide detailed concepts of relays and comparators. It adds credibility to the presentation. Thank you.